Hello everyone and welcome to Tuesday's maths lesson. Today we're going to be continuing to think about coordinates, but before we do that we're going to remind ourselves of some of the properties of 2D shapes and some of the language that we use around them because they will come up in some questions later on in today's activity. Before we start, you will need a pen or pencil and a square piece of paper if you've got it. If not, a plain piece or a lined piece of paper is absolutely fine. As you go through the video, I will let you know when there's activities and you can pause the video and do the activities as you work your way through. And then please do upload the work to Dojo, to Portfolio, so that I can give you some feedback. First of all, let's have a look at properties of 2D shapes and some language. So we've got here curved, straight, longer, shorter. Sides, you can see that they are the sides of the shapes, which are here. Equal, when everything is the same. Two-dimensional, that means something is flat, it's just drawn on paper. A vertex or vertices, which is the corner of a shape. Symmetry is a line where there is the same on both sides. And length, how long something is. When we talk about properties of 2D shapes, there are also other words that we can use and language associated with them. So we have an obtuse angle, an angle that is larger than 90 degrees, larger than a right angle. A right angle, which you can see here, which is 90 degrees, just like the corner of a page. An acute angle, an angle that is smaller than 90 degrees, it's smaller than a right angle. We have at the bottom here a perpendicular line, so it's a line that's at a right angle at 90 degrees to another line. And a parallel line, a line that is next to another line, but if you were to continue to draw them, they would never meet. Let's have a reminder of some of our 2D shapes, and we will be using those in our coordinates lesson today. A reminder about a square. Squares have 4 sides, they have 4 vertices, and all angles and sides are equal. Be careful when spelling the word square. We have here a rectangle. Rectangles have 4 sides and 4 vertices. All of the angles are right angles. A square is a special type of rectangle with all of the sides the same length. An equilateral triangle. Equilateral triangles have 3 sides, they have 3 vertices, and angles all measure 60 degrees, so all of the angles are equal. The children in class will be used to seeing these 2 lines on each side to show that they are equal. A scalene triangle. Scalene triangles have 3 sides, 3 vertices, and what is special about them is that their 3 sides are all of different lengths. We have here our right angle triangle. So right angle triangles have 3 sides, 3 vertices, and they contain an angle of 90 degrees, which you can see here, and is often drawn with that little square in the corner to show that it is a right angle. It is 90 degrees. An isosceles triangle, this one is super tricky to spell. They have 3 sides and 3 vertices, and they have 2 sides here of equal lengths, which you would demonstrate with the 2 lines. A trapezium. A trapezium has 4 sides and 4 vertices. 1 pair of opposite sides, which are parallel. That's this line here and this line here. And these 2 sides are not parallel because if you continue drawing them, they would end up touching. A parallelogram has 4 sides, 4 vertices. Opposite sides of equal length. So these 2 sides are equal and these 2 sides are equal. And opposite sides which are parallel, so you could continue to draw these lines and they would never meet. A rhombus has 4 sides, 4 vertices, and all sides are of equal length. So just like a square, opposite sides are parallel. These sides are parallel and these sides are parallel. Pentagon is our 5-sided shape and also has 5 vertices. A hexagon is a 6-sided shape with 6 vertices, and an octagon is an 8-sided shape with 8 vertices. And finally, we have circle, which is another tricky one to spell. They only have 1 side, 1 curved side, and they have no corners. After that reminder of 2D shapes, we're going to move on now to our work using coordinates today. So you will need to have your pencil and your piece of paper with you, and I will show you each slide and talk you through the activity, and then you can pause the video and have a go yourself, and that is the work that you will be uploading onto Dojo today. The first job. When plotted, which coordinates will make a parallelogram? You need to plot all of these coordinates and see which 4 you could join, because a parallelogram has 4 vertices, which 4 you could join to make a parallelogram. If you need to wind back the video to remind yourself of what a parallelogram looks like, you can do that. The next activity. Can you please plot the points for the coordinates on the grid? So your job for this activity is to just plot the points for the coordinates on the grid. So if you pause the video. This activity asks you to draw a right-angled triangle. Start at point A and write the coordinates for the other points. There are lots and lots of different ways you can do this. Remember that a right-angled triangle is 90 degrees like the corner of a page. You can choose how large or how small your triangle is. And if you'd like to give me a few different suggestions of the coordinates for a right-angled triangle, please do. These are the coordinates for the vertices of a square, true or false. Could you please mark these coordinates onto the grid and then tell me whether they create a square or not? Tell me why, true or false. Chloe is plotting coordinates. Explain her mistake. So you need to look at each point and see the coordinates and see whether they're correct or not. The penultimate activity. You need to identify and plot 6 pairs of coordinates, each with a total of less than 10. So for example, you could have 7 and 2 because that makes 9. You could, for example, have 0 and 8 because that makes 8, which is less than 9. So you need to plot those coordinates and please write those down for me. The last activity today. Plot 2 missing coordinates to make a letter made up of straight lines. They've given you some of those already, and I will give you a big clue, and I'm going to say symmetry. So have a go and see if you can plot the missing coordinates to make a letter of straight lines. So going through working with the coordinates, remembering along the corridor and up the stairs like we did yesterday, and trying to remember those shape names in the shape language that I recapped at the start of this lesson. I look forward to seeing your work uploaded to Dojo, and if you've got any questions or queries in the meantime, just drop me a message.